All right, so the cosine rule is just another way of looking at non-right angled triangles. And it's another way of finding a side length or a angle. Um, but usually when we're given either two side lengths and a angle, and we're finding a third side length, or we'd be given three side lengths and we are trying to find the angle. Okay, so the two formulas, okay, that we have, okay, they are the same formula, just rewritten, but I will give you both of them. So the formulas are c squared is equal to a squared plus b squared minus 2ab cos c. Okay, and this one is if you have two sides, one angle, and you're finding a side. Okay, and the second formula is cos c is equal to, now I've got to get this right, a squared plus b squared minus c squared over 2ab. Okay, and this is when you've got three sides and you're finding an angle. Okay, it's a little bit different to the sine rule, because the sine rule is when you've got two sides or two angles and one of the other and trying to find the second of the other. This is when you're doing the third of something. So you've got three sides and finding the angle, or you've got an angle and two sides and finding the third, okay? So let's have a look at the application of this. Now, this one doesn't have any tricks like the sine rule does, okay? The cosine rule is much, much more straightforward. But I want you to notice, though, that with the cosine rule, the first part of this here may look very, very familiar to you. And it is it looks like Pythagoras. Okay, so why does this look like Pythagoras? Okay, well, what would happen if I was to put 90 degrees into this formula? Okay, I'm going to leave that as a little exercise for you to do. Okay, so if I had 90 degrees, which makes a right angle triangle, what happens to this formula? Now, let's have a go at an example of this, and we'll start off by looking at by finding a side length. Okay, so how about we do find the perimeter, and I think I spelled perimeter wrong. I think it's here. Find the perimeter of, and drop our triangle like this, and we'll actually connect it. Shapes are hard. Like this. Okay, 2 centimeters, 3 centimeters, and oh, I don't want a right angle in there. Sorry, it's not even a right angle anyway. Say like 102 degrees, something close to 90 degrees. Okay, so if we're finding the perimeter of this shape, of course we need to find what all three lengths are. Now, if that was a right angle, it'd be very straightforward. We just have to use Pythagoras' theorem. Okay, but it's not a right angle triangle, so we're going to have to use this cosine rule from above. Okay, we'd have to use this one here. Okay. So let's start off by labeling our sides. So I'm going to call this side my side C. Okay, I'm going to write the formula down. So I'll do it over here. C squared is equal to A squared plus B squared minus 2AB cos capital C. Okay, now C is my unknown side, so my capital C is the side that's opposite. Now, it doesn't matter which side I call A and B, as long as they are next to the angle that I am using, okay? So A and B must be either side of the angle that I am going to use in the formula, okay? So if I had two angles, say this one down here was 30 degrees as well, okay, I'm not going to call this side A and this side B if I'm still using the 102 degrees, okay? I have to use the sides that are either side. All right, let's substitute some values in. So we've got c squared is equal to, well, a is 3 squared. Now, it doesn't matter if I do the a is 3 and the b is 2, or the b is 3 and the a is 2. It doesn't matter which way they go, as long as they're next to the as long as it's next to the 102. 2 squared minus 2 times 3 times 2 times cos 102 degrees. Now, we could write c squared is equal to all this, or we could just write, we know that c squared is equal to that. So c is going to be equal to the square root of 3 squared plus 2 squared minus 2 times 3 times 2 times cos of 102 degrees, okay? So c is going to be equal to, okay, so 3 squared, square root of 3 squared plus 2 squared minus 2 times 3 times 2 times cos 102. Close it off, we get 3.9, let's go to 2 decimal places, 3.94, okay? Now, we've found what that side length is equal to, but we need to find what the perimeter is. So the perimeter, just add up the sides now. So 3 plus 2 plus 3.94, and that gives us 8.94, and it is centimeters. So that is the perimeter of that triangle, okay? So basically just using that formula and then adding up the side lengths, pretty straightforward, I think. Now let's try another example now. And I think this time we will try and find a side length, an angle this time. So we'll have an application of the angle. Okay, so here's a triangle. I'll draw my theta in here. Let's put a 13, a 12, and an 8. Okay. Now, theta, we're finding theta, so let's have a look at our formulas. We're using formula number 2 for this one, okay? So let's write down our formula. So I'll write it down here. We've got cos c is equal to a squared plus b squared minus c squared all over 2ab cos c. Cos c? No, there's no cos c down there. Just 2ab. So let's substitute in the values we know. So we need to label our triangle first. So we're calling this corner our C corner, okay? Which means that we need to label our A and B on either side of this angle that we've got, okay? So this side is my A side, this side is my B side. That means that this side here must be my C side, and it's also the side that's opposite to. Just like we did with the sine where we had to label it the opposites, we've got to do the same thing for our cosine rule too. Excuse me. Okay, so my A is equal to 13, my B is equal to 12, and my C is equal to 8, okay? So let's plop those into this formula. We get 13 squared plus 12 squared minus 8 squared over 2 times 13 times 12, okay? And this is what cos C is equal to, okay? Cos C is equal to this, okay? But we don't want to know what cos C is equal to, right? We don't want to know what cos C is equal to. We want to know what cos is equal to, right? Okay? So, sorry, we don't want to know what cos is. We want to know what C is equal to. We want to know what our angle is equal to. We want to know what our theta value is equal to, what our angle in there is equal to. So how do I get the theta by itself? How do I remove the cos from the left-hand side to the right-hand side? Well, hopefully you remember from the previous lessons when we did this, we found the angles using just the regular trig ratios, that we do this inverse cosine notation, okay? Now I can put my whole thing in here, okay? Like this. Okay, you don't have to simplify it, you can just write the whole thing in. Okay, like that. And you can put this straight into your calculator as it stands. You can do the simplification step first, Okay, but I like to put the whole thing in just so I know I don't make any mistakes and I can check. So 13 squared, and I want to put it on a fraction. 13 squared plus 12 squared minus 8 squared over 2 times 13 times 12. Okay. Close it off, and we get 37 degrees. And let's go to the nearest minute. 3 minutes. Okay. So that's angle in there is about 37 degrees, okay? So I hope that's made sense on how to do that, guys. Okay, pretty straightforward, I think. But nonetheless, I'll leave it with you guys to have a go at. And with that being said, I'll leave it with you. And we've only got one more lesson on trig, which is the area, and then we're all done. So, yeah, I'll leave it there.